Have you ever imagined that a small creature like a crab could be deadly? Thank God for giving us so much to explore. And in today's video, you'll meet 15 of the most dangerous crustaceans on the planet, creatures with hard shells, bizarre shapes, and lethal abilities that seem straight out of a horror movie. With their sharp claws, paralyzing venom, and cold-blooded predatory behavior, these creatures will completely change the way you think about shrimp and crabs. Get ready to be amazed, fascinated, and maybe even think twice before your next dive. But before we start, make sure to subscribe to our channel and leave a like. Now let's begin. Number 1. American lobster, nature's tank. The American lobster, Homarus americanus, is not merely a luxury seafood item. It is one of the most fascinating and resilient creatures of the marine world, a living symbol of evolutionary ingenuity. Native to the cold, rocky waters of the North Atlantic, ranging from Labrador in Canada to New Jersey in the United States, this crustacean has adapted over millions of years to survive in challenging conditions, from strong currents to predators like cod, flounder, seals, and even humans. Its existence is a story of armored survival, strategic hunting, and complex social behaviors, all packaged within an exoskeleton that rivals medieval armor in effectiveness. Anatomy and armor. The lobster's body is covered by a rigid exoskeleton made of chitin, reinforced with calcium carbonate, giving it the structural strength to resist both physical attacks and the pressures of deep waters. Unlike many other marine animals, lobsters have articulated joints in their exoskeleton, which allow them to move with precision despite the armor's weight. Their two primary claws are asymmetrical. The crusher claw, thick and powerful, is designed to break shells and crush prey, while the pincer claw is long, sharp, and dexterous, ideal for slicing and tearing. Remarkably, if a claw is lost due to a predator attack or accident, lobsters can regenerate it over successive molts. This regenerative ability is not limited to claws. Legs and antennae can also regrow, making lobsters among the most resilient arthropods in the ocean. Inside their armored exterior, lobsters are equipped with highly specialized systems. Their stomach contains a gastric mill, a set of calcified plates that grind food before it enters the digestive tract. This mechanical system allows lobsters to process a wide range of foods, from mollusks and small crustaceans to algae and detritus, making them versatile omnivores. Their antennae and tiny hairs along their legs function as sensitive chemical and tactile sensors, allowing them to detect prey, predators, and even mates in near total darkness. Behavior and survival strategies. Lobsters are largely nocturnal, spending daylight hours hiding in rocky crevices or burrows, emerging at night to hunt or forage. They are territorial animals displaying complex dominance behaviors. When two lobsters encounter each other, they often engage in ritualized displays, raising claws, circling, and vibrating their bodies. Such encounters usually determine hierarchy without direct combat, but when fights occur, they can cause significant injury or even death. Molting is another critical aspect of lobster survival. To grow, lobsters periodically shed their old exoskeleton and expand their soft new shell before it hardens. During this period, they are highly vulnerable to predators and environmental hazards. Lobsters often hide in tight crevices and rely on their chemical senses to detect threats. Interestingly, molting frequency decreases with age. Juveniles may molt several times a year, while adult lobsters molt once every 1 to 2 years, meaning that a large adult survival relies on centuries of accumulated experience navigating a dangerous environment. Reproduction and life cycle. American lobsters have a slow reproductive cycle, which contributes to their longevity and ecological significance. Females carry eggs under their tail for 9 to 12 months, sometimes holding tens of thousands of eggs, depending on size. Once hatched, larvae are planktonic, floating with ocean currents for several weeks before settling on the seabed. Juveniles face high mortality rates due to predation, but those that survive will gradually grow, molt, and develop the complex behaviors and powerful claws that define adult lobsters. Mature lobsters can live over 50 years, making them among the longest-lived crustaceans on Earth. Ecological importance. In the North Atlantic ecosystem, American lobsters are both predators and prey, playing a pivotal role in maintaining ecological balance. Number 2. Eggflower crab, the ocean's lethal jewel. The Eggflower crab, scientifically known as Atargates floridus, is one of the most fascinating and dangerous marine creatures on the planet. Small, usually the size of an adult human hand, it immediately draws attention with its appearance. A shell adorned like flower petals, or an underwater luxury brooch. Its vibrant colors ranging from deep red to golden orange, with intricate patterns make it a true masterpiece of nature. But beware, its beauty is deceptive, hiding a deadly secret. Native to the tropical waters of Southeast Asia, including Indonesia, the Philippines, Japan, and northern Australia, the crab prefers rocky coastal areas or coral reefs, hiding among crevices, algae, and coral. Its tough shell protects against attacks, while agile legs allow for swift, stealthy movements. The real danger of Atargates floridus is chemical. It contains tetrodotoxin, the same neurotoxin found in the puffer fish, fugu. This toxin blocks sodium channels in nerve cells, causing rapid paralysis, respiratory failure, and in sufficient doses, death. To put it into perspective, the crab's tetrodotoxin is up to 12,100 times more lethal than cyanide. And cooking the crab does not neutralize it, even tiny amounts can be fatal. Interestingly, the toxin isn't produced by the crab itself, but by symbiotic bacteria in its body. This chemical defense ensures the species' survival, protecting it from larger fish and seabirds. Besides its venom, the Eggflower crab is omnivorous, feeding on small mollusks, algae, and organic debris. Its front claws are strong and precise, able to crack shells and capture prey efficiently. Despite its chemical lethality, it is not aggressive toward humans unless threatened or handled. Ecologically, it plays an important role, controlling populations of smaller invertebrates and keeping reefs clean. Its burrows also provide microhabitats for other species. Historically, fishermen and divers have always admired its beauty, nicknaming it the reef jewel or ocean brooch. From a scientific standpoint, tetrodotoxin is studied to better understand nerve transmission and to develop powerful painkillers. Number 3. Giant spider crab, the guardian of the depths. If the legendary sea monsters were real, none would be as impressive as the giant spider crab, scientifically known as Macrocara camphori. This colossal crustacean, found mainly in the cold waters of Japan, is the largest arthropod on the planet, with legs that can span an astonishing 3.8 meters and a body weighing nearly 20 kilos. Despite its terrifying appearance, long, thin legs, spiny carapace, and protruding eyes, it is a shy, slow, and in some ways peaceful creature native to the Western Pacific, especially around Honshu and Hokkaido. The giant spider crab inhabits depths ranging from 150 to 300 meters. These dark, cold areas are nutrient-rich but host natural predators, such as large octopuses and some deep-sea fish species. To survive, the crab has developed highly effective camouflage, sponges, algae, and small organisms attached to its carapace, making it nearly invisible to predators and curious divers. This behavior not only protects the crab, but also provides shelter for microorganisms, creating small mobile ecosystems on its body. Macrocara camphori's diet is predominantly carnivorous and opportunistic. It feeds on dead animals, fish scraps, mollusks, and other crustaceans, acting as a natural cleaner of the seabed. By recycling organic matter, the crab contributes significantly to the ecological balance of deep habitats, preventing debris accumulation and promoting nutrient cycling. Studies show it can capture live prey using its long, powerful claws, but also consumes leftovers, demonstrating impressive dietary flexibility. In addition to its diet and camouflage, the giant spider crab has fascinating biological traits. Its lifespan can exceed 100 years, making it an ancestral species that has survived multiple climate changes and environmental pressures over millions of years. It grows slowly, with molting occurring only once per year in adulthood, and sometimes only every 2 years, depending on food availability and water temperature. This slow growth, combined with longevity, makes it a living record of Pacific oceanic history. Giant spider crab reproduction is also notable. Males and females meet in specific seabed areas during mating season, usually in spring. After fertilization, the female carries thousands of eggs under her abdomen until hatching, releasing microscopic larvae that undergo several planktonic tectonic stages before becoming benthic juveniles. This complex cycle ensures the species' survival in a challenging environment, but also means the population is vulnerable to environmental changes and intensive fishing. Speaking of fishing, the giant spider crab is highly valued in Japanese cuisine, known as kagani or tarabagani in luxury restaurants. Nevertheless, strict regulations exist to prevent overfishing, given its longevity and slow growth. Harvesting young or excessive individuals can destabilize entire populations and impact the delicate seabed ecosystem. Interestingly, selective fishing has also encouraged the development of sustainable techniques, such as using specific traps that capture mature adults without destroying underwater habitats. Beyond its economic value, the giant spider crab sparks scientific and cultural fascination. Japanese historians and archaeologists have found references to this species in Edo period texts and illustrations, indicating it was admired for its size and rarity centuries ago. In modern biology, it serves as a model for studies on longevity, limb regeneration, and deep sea adaptation. Its unique anatomy with elongated joints and a sturdy exoskeleton inspires researchers in robotic engineering and biomimetics. Number 4. Remipedes, the terror of submerged caves. If the horrors of underground depths had a shape, they would probably be remipedes, small predators that resemble ghostly centipedes. Commonly found in flooded cave systems in Mexico, Belize, and parts of Central America, these aquatic arthropods measure at most 4 centimeters, but do not be fooled by their tiny size. They are sophisticated predators, adapted to an extreme environment where survival requires lethal and precise strategies. Remipedes belong to the class Remipedia, an ancient line of crustaceans with fossil records dating back to the Cretaceous period. This means these creatures have survived millions of years of geological and climatic changes while maintaining almost the same morphology. Their appearance is both fascinating and frightening: segmented bodies, multiple jointed legs, and long sensory filaments that substitute for vision as they are completely blind. Adapted to the complete darkness of submerged caves, their sensory organs are incredibly refined, able to detect minimal vibrations and water currents, locating prey with surgical precision. Remipedes' habitat is limited but ecologically unique. They live in brackish groundwater and cenotes, flooded caves connected to rivers and subterranean water systems. Food scarcity is constant and competition is intense. To survive, remipedes have developed an extremely efficient and lethal hunting technique. They use their jaws to inject a mixture of neuroparalytic toxin and digestive enzymes directly into prey. The toxin instantly paralyzes small crustaceans and cave fish, while the enzymes begin internal digestion, liquefying tissues. Within minutes, the predator simply sucks the contents like soup, extracting every available nutrient. The study of remipede venom has attracted neuroscientists due to its effectiveness and chemical complexity. Research indicates that some of their toxins act similarly to snake venom, blocking sodium and potassium channels in prey neurons, although effects on humans are practically unknown due to the isolation of their habitats. The potency of their venom is a reminder that nature, even in tiny creatures, can produce highly specialized chemical weapons. Remipede social behavior is also fascinating. They are predominantly solitary, but have been observed interacting in small aggregations when resources are abundant. In such encounters, they subtly compete for territory and food, using sensory antennae to assess an opponent's strength before any direct physical confrontation. This combination of caution, sensory intelligence, and predatory skill makes remipedes an extreme example of evolutionary adaptation in near-total isolation. From an evolutionary standpoint, remipedes are considered living fossils, a link between primitive crustaceans and modern species. Their anatomical features, such as elongated bodies, multiple segments, and uniform swimming appendages, reflect an ancient design, perfect for efficient swimming in confined, turbulent cave waters. Studying these animals allows scientists to understand how species can specialize in extremely restricted niches and survive through geological eras without significant morphological changes. Despite being deadly predators, remipedes are vulnerable to environmental impacts. Groundwater pollution, cenote exploitation, and changes in subterranean river flow can devastate their populations. Unlike surface predators, they cannot easily migrate, making each cave system a critical and isolated microhabitat. Conservation of these environments is essential not only for remipedes but for the entire subterranean biodiversity, including blindfish, mollusks, and other endemic crustaceans sharing the same ecosystem. Number 5. Pistol shrimp, The shooter of the seas. The pistol shrimp, commonly known as Alpheus bellulis, or in some varieties Alpheus pink Floyd, is one of the most impressive and enigmatic marine creatures in the ocean. Small, usually no larger than an adult's pinky finger, it has a disproportionately large claw that functions as a true underwater weapon. Although its appearance is delicate and almost fragile, the pistol shrimp can perform physical feats that defy expectations of size and strength. The larger claw is not just an ornamental appendage, it is a sophisticated and deadly instrument. When the shrimp snaps, it shuts quickly. It fires a jet of air bubble that moves at extreme speeds, reaching over 100 km/h. The pressure of this bubble creates a shockwave capable of stunning, incapacitating, or even killing small fish and other crustaceans. The impact is accompanied by an impressive popping sound, reaching up to 210 decibels, louder than a jet engine or a firearm. In home aquariums, pistol shrimp can even damage thin glass just with their defensive snap, making them a challenge for unsuspecting aquarists. Beyond its mechanical strength, the pistol shrimp has a fascinating ecological relationship. Many species form symbiotic alliances with gobies, where the shrimp digs and maintains burrows in sandy or rocky bottoms, providing safe shelter for both itself and the fish. In return, the goby acts as a lookout, alerting the shrimp to predators with subtle tail or body movements. This partnership is a classic example of mutualism, where two very different species benefit from each other, showing that the pistol shrimp is not only an efficient predator, but also a habitat engineer and social strategist. Its feeding behavior is equally fascinating. While the giant claw is primarily used as a weapon, it also helps the shrimp capture smaller prey, crush shells, and open mollusks to consume their contents. It is omnivorous, feeding on small invertebrates, algae, and organic detritus. The precision with which it snaps its claw to create a shockwave is extraordinary, a skill honed from a young age. Research indicates that the claw closes so rapidly that the surrounding water enters a state of cavitation, forming a vapor bubble that collapses with such energy it produces a brief flash of light called sonoluminescence, a rare and striking phenomenon in the animal world. Pistol shrimp reproduction is also interesting. They exhibit sexual dimorphism, and during mating season, males and females perform complex dances within their burrows. The female lays eggs, which are carefully protected until hatching, with the young learning to handle the giant claw safely before venturing outside the burrow. This early learning is essential as the claw serves both as a hunting weapon and a defense against larger predators. The ecological impact of the pistol shrimp is significant in marine environments. By digging and maintaining their burrows, they increase oxygenation of the sandy substrate, improve nutrient circulation, and create microhabitats used by other invertebrate species and small fish. Their presence is not just a display of strength, they positively modify the local environment, acting as ecological engineers that support biodiversity. Interestingly, the pistol shrimp has also inspired technological and biomimetic research. Scientists study its claw as a model for precise underwater weapons and analyze the cavitation it produces for applications in fluid engineering and acoustics. The ability to generate shock waves and powerful snaps in such a small space impresses engineers and marine biologists alike, demonstrating that nature can create incredibly efficient miniature weapons. Despite its fame as a deadly predator, the pistol shrimp faces natural threats such as seabirds, larger fish, and even other crustaceans. Number 6. Marbled crayfish, the self-cloning female. Visually similar to a small crayfish, this crustacean is a walking genetic threat. It first appeared in a German aquarium in 1995, following a spontaneous mutation. Remarkably, all individuals are female and reproduce by parthenogenesis, natural cloning. Each female produces hundreds of identical copies without the need for a male. This self-generated legion has spread rapidly through lakes and rivers in Europe and Africa, pushing out native species, destroying habitats, and destabilizing entire ecosystems. Classified by the European Union as a priority invasive species, it has even taken over small lakes and residential gardens, as if a miniature ecological dystopia had come to life. Number 7. Chinese mitten crab, the disguised invader. At first glance, the Chinese mitten crab, also known as Ariocaire sinensis, looks almost like a creature out of a storybook. Small claws covered in fine hair resembling little gloves, a rounded body, and a curiously cute appearance. However, this cuteness is only a facade for a highly destructive invader native to rivers and estuaries of China, Japan, and Korea. Despite its relatively small size, usually 6 to 10 cm across, the impact it can have ecologically and economically is enormous. The Chinese mitten crab was accidentally introduced to rivers in Europe and North America during the 20th century, mainly through ship ballast water. Once established, it spread rapidly, demonstrating incredible adaptability to different climates and habitats. In European rivers, such as the Elbe in Germany and the Rhine, populations multiplied quickly, forming dense colonies that dig complex tunnels along riverbanks. These tunnels often cause erosion, destabilize dikes and dams, and increase the risk of flooding. The strength of these small creatures is enough to compromise engineering structures, turning an apparently harmless crab into a threat to human infrastructure. In addition to physical impacts, the crab is a significant public health risk. It carries the parasite Paragonomus westermani, the lung fluke, capable of infecting humans if the crab is eaten raw or undercooked. Infection, known as paragonomiasis, can cause chronic cough, chest pain, fever, and in severe cases, pulmonary and extrapulmonary complications. This makes the crab not just an environmental problem, but also a health concern. Its behavior contributes to its invasiveness. Omnivorous and opportunistic, it feeds on aquatic plants, mollusks, small fish, and organic debris. This varied diet allows it to establish quickly in new environments and compete directly with native species, often reducing local populations of crustaceans and fish. Its ability to migrate between freshwater and brackish water during different life stages increases its invasive potential. Juveniles typically move to estuarine environments, while adults inhabit rivers and lakes, creating a network of interconnected populations that is extremely difficult to control. The ecological impact of the Chinese mitten crab is also seen in habitat alteration. By digging tunnels and excavating riverbanks, they destroy waterbird nests and reduce spawning areas for native fish. The intense digging activity increases water turbidity, affecting photosynthesis in aquatic plants and altering the local food chain. In some regions, entire ecosystems have had to adapt to the invader's presence, modifying predator-prey relationships and reducing biodiversity. From a management perspective, the Chinese mitten crab presents enormous challenges. Physical traps, chemical control, or manual removal are often insufficient due to its high reproductive rate. A single female can produce tens of thousands of eggs per year, and its ability to disperse along rivers and estuaries. Eradication efforts can also have collateral impacts on native species, making environmental management even more complex. Its biology is fascinating. The hairy claws are not just for intimidation. The hairs help capture food particles and detect water movements, acting as highly sensitive sensors. The species has a semi-stratified life cycle. Juveniles live in saltwater and migrate to freshwater, while adults return to estuaries to reproduce. This long-distance migration contributes to continental dispersal, making complete population control impossible once established. Number 8. Edible crab. The record-breaking pincher native to the North Atlantic seabed, this crab can reach 30 centimeters in width and weigh up to 4 kilos. Its claws exert a brutal pressure of 90 kilos per square inch. Omnivorous and opportunistic, it eats mollusks, dead fish, and even other crabs. Its cannibalistic and predatory behavior is balanced by its commercial importance. In the UK alone, thousands of tons are harvested each year. Females carry up to 2 million eggs, released into the sea to drift before settling. During migrations, they travel kilometers in search of food or breeding grounds. Despite their strength, they are vulnerable during molting, becoming prey to octopuses and large fish. Nevertheless, they are key players in maintaining the stability of marine ecosystems. Number 9. Mantis shrimp, the fastest punch in the ocean, colorful and deadly. The mantis shrimp may seem harmless at just 20 centimeters long, but it is a true fighting machine. Its specialized appendages strike at an astonishing speed of 80 km/h, producing even explosive bubbles with secondary shockwaves that can neutralize prey. It has unparalleled vision, with 16 color receptors, polarization detection, and independently moving eyes. There are over 400 species, divided between smashers and spearfish. God-fearers. Beyond being fierce hunters, they display impressive social behaviors, recognize neighbors, follow combat rituals, and even form monogamous pairs. Their shell is so strong that it inspires research into ultra-durable materials and engineering. Number 10. Coconut crab, the nighttime coconut thief. Imagine being on a remote Pacific island and suddenly encountering a crab the size of a child. The coconut crab, nicknamed the coconut thief, is a terrestrial monster capable of lifting up to 28 kilos and delivering a bite 10 times stronger than a human hand. Weighing about 4 kilos, measuring 40 centimeters, with legs extending nearly 1 meter, it is the largest terrestrial arthropod in the world. At night, it climbs 10-meter trees to cut coconuts and drop them to the ground. Then it uses its powerful claws to open the fruit and devour the flesh. Although solitary and nocturnal, its diet is varied: fruits, seeds, small animals, and even carrion. It can live up to 60 years, regenerates lost limbs, and takes shelter in burrows during molting when it is vulnerable. Number 11. Emerald crab, the poison jewel of the Caribbean. We conclude the list with one of nature's most beautiful crustaceans, the emerald crab, also known as Metraculoscoptus, with its fluorescent green hue and almost extraterrestrial appearance. It moves among Caribbean corals like a living jewel. Small and primarily feeding on algae, it can even be a helpful ally in aquariums. But outside this controlled environment, it may carry toxins dangerous to humans, especially if accidentally ingested. Its harmless appearance makes it even more treacherous. Like many natural gemstones, its beauty comes with a warning: not everything that shines is safe to touch. Number 12. Cookie crab, the dish that can kill, with a name reminiscent of a restaurant dish. The cookie crab, Platypodia granulosa, looks appetizing. Its round brown shell resembles a fried pastry hidden among rocks and corals in the Indo-Pacific. But don't be fooled, this inviting appearance hides deadly venom. It contains neurotoxins that even heat cannot neutralize. A simple touch can trigger severe reactions, especially in allergic individuals. While not aggressive, the real danger lies in its deceptive appearance. Mistaking it for a seafood treat can be fatal. Not everything that comes from the ocean is ready for the plate. Number 13. Tidal crab, the submerged living trap. The tidal crab, despite its poetic name suggesting delicacy, is anything but harmless. Scientifically known as Silacerata, it is one of the most formidable and treacherous crustaceans found in the coral reefs and mangroves of Southeast Asia and the Pacific, including Vietnam, Singapore, Indonesia, the Philippines, and New Caledonia. With a body about 50 centimeters long, but legs and claws extending much further, it combines brutality and evolutionary perfection, becoming a true underwater predator and a living trap for unsuspecting creatures, including humans. At first glance, it looks almost mechanical. Its robust body is covered in razor-sharp spines designed for defense and intimidation. Each claw and leg has serrated edges, creating an industrial-like appearance, as if nature forged a living underwater machine. These structures aren't merely decorative. They help grasp prey efficiently, tear apart other crustaceans, and even crush mollusk shells. Accidentally stepping on it can cause deep cuts, bleeding, and intense pain. And the risk doesn't end there. The real danger lies in its internal chemistry. Its flesh and bodily fluids contain potent toxins that can cause nausea, muscle paralysis, and in extreme cases, respiratory failure. Unlike some marine species whose venom only manifests on contact, this crustacean retains toxicity even after death, meaning that accidental consumption of its meat, if undercooked or improperly prepared, can be fatal. Poisoning can occur silently, often without immediate symptoms, making it especially treacherous. Ecologically, the tidal crab is an opportunistic predator and an important regulator of coral reef and mangrove ecosystems. It feeds on small fish, mollusks, marine worms, and even smaller crustaceans, keeping these populations under control. Its voracity, combined with powerful claws, allows it to dominate territories and food resources with near military efficiency. Its digging activities help oxygenate the seabed, indirectly supporting ecosystem health. Although overpopulation can lead to localized destruction, its behavior is both fascinating and terrifying. Territorial and solitary, it aggressively defends its space. During low tide, it can be seen moving between sandbanks and shallow reefs, searching for food or digging secure burrows. These burrows are complex, with multiple chambers and exits, functioning as true submerged fortresses. This digging skill, combined with natural aggression, makes it an almost unbeatable predator in its environment. Culturally, in some parts of Southeast Asia, the tidal crab is a valued delicacy, but its preparation requires extreme care. Skilled cooks know precisely how to remove toxins and use specific cooking techniques to ensure the meat is safe to eat. Nevertheless, accidents still occur, and poisoning reports are common in coastal communities less aware of the risks. This contrast between danger and gastronomic appreciation illustrates how a creature can be both admired and feared, depending on human context. The tidal crab also serves as a warning about the delicate relationship between humans and marine ecosystems. It teaches that the beauty or size of an animal does not always indicate its danger. Even the most colorful and paradisiacal oceans hide silent predators and living traps that challenge our understanding and respect. In summary, the tidal crab is far more than just a reef crustacean. Number 14. Mangrove crab, the ninja of the swamps. In the turbulent mudflats of mangroves in Asia, Africa, and Oceania, a patient predator lurks beneath the mud, the mangrove crab. While highly valued in cuisine and widely fished, this crustacean is far from fragile. With claws as sharp as knives, it buries itself in the mud and waits invisibly for the right moment to strike. When defending itself, it can deliver blows capable of cutting skin and even breaking bones. There are reports of claws that continue to pinch even after being severed, as if they had a will of their own. And most impressively, if it loses a claw, it simply regenerates another and returns to battle, like a warrior coming back to war with a new sword. Number 15. Mosaic crab, small, shiny, and lethal. With its carapace in vibrant orange tones and white patterns reminiscent of carnival confetti, the mosaic crab looks like it came straight from a parade, but behind its festive appearance hides one of the most poisonous animals on the planet. Measuring only 10 centimeters, this crustacean inhabits reefs and coasts of countries like Singapore, Indonesia, Japan, Vietnam, and Australia. Despite its small size, it has no competition when it comes to venom, and this is just the beginning. Next, we'll explore even scarier creatures like this one. You'll certainly be surprised. Like the video, share it with your friends, and subscribe to the channel to discover more interesting things. Thank you so much for watching. If you enjoyed this video, make sure to subscribe and hit the like button. Also, check out other videos appearing on your screen right now. I'll see you in the next video.